So we just want to do a couple more examples as we just get more comfortable. We're not introducing anything new. We're just reinforcing the skills that we did yesterday. We're just going to continue to practice. So we want to talk today about an oil spill. Okay, environmentalists, as soon as they hear about some kind of oil spill, like you start to think about how are the wildlife affected, how's the coastline affected. So let's imagine that there's an oil tanker that has a leak out there, and the leak is going to be perfectly circular. All right, we know that that's probably not real life, that we're not going to have it's going to be more like a blob shape, but we'll say for our purposes it's a circular oil slick. Okay, in fact, the oil slick isn't just a circle, but it does have depth to it as well. So it's like a great big cylinder, but the cylinder is just hardly deep because it's floating on the surface. So we are looking at the volume of a cylinder. So you just have to imagine that you've got this oil spill that's super wide, but just not very deep at all. We are still looking at volume. Yeah? Okay. All right, and so we have the diameter and we have the radius. So we're looking at a couple things. If we were doing volume, we're going to do pi r squared h. If we're going to do just the area of the top of the slick, it'll just be pi r squared. So that's our geometry. Are we talking about the whole thing? So we're going to use the units as a clue. Okay, looking at the units that we've got and looking at the question. So at the time that the slick's radius is growing at 3.5 meters per minute, the diameter is 150 meters. At what rate is the area? Okay, so there's our clue. We're looking for the area. So we want to do dA dt. So we'll take the area equation and we'll find dA dt from that. So we'll take the derivative. That'll be 2 pi r times dr dt. So we've got our derivative going there. Now we'll just drop in our values. We are trying to answer the value of the area, so we'll be looking to answer that question. And we're freezing the time. Okay, we're doing a stop motion. Okay, stop. And the slick was growing, but we're going to do a freeze motion, and we're going to plug in R. All right, what goes in for R? 75. Nice, 75. All right, not 150. We're told that the diameter is 150, but you have to infer then that the radius is 75. The radius is growing, so we have a positive number at 3.5 meters per minute. So this is a pretty straightforward one where all the numbers drop in nicely. So 7 times 75, what is that, 225? 225 pi. I multiply. And then I need to attach my units to that, so dA dt. So I might measure the area. The units for the dA will be meters squared, and the units for the time will be minutes. So that was a pretty straightforward one.
Isn't that times 5?
Oh, I only multiplied by 5, so add another 150, so what, 375? Why am I not doing math right in my head? Thank you. All right, last one. Okay, a train. You're standing on the platform where a train is going to pass you by. You see the train coming, and you're waiting for that. I like to imagine. I like to camp at San Clemente. If you've ever been to San Clemente, there are cliffs at San Clemente, and at the base of the cliffs are the train tracks come by. So when my kids were younger, they would hear that train whistle and they'd run to the edge and wait for the train to come by. So you're standing there waiting for this train to pass you by. The train is traveling east. That's going to be important. The observer is 70 meters south of the intersection, and then we want to freeze this at a moment in time. All right, so here's the train tracks. Okay, my train is heading that direction. So my train is going that way. The observer is standing south and then watches the train pass by. as the train is passing and the person is watching the train go, the first time the person sees the train is over here. So what shape is formed? Triangle. And as the train moves, okay, now the triangle changes, and then when the train is right in front of the person, we just have a straight line. We don't have a triangle anymore. And now the train is moving that direction. Okay, so we've got this as we're following the train traveling east. All right, we are freeze framing this 4 seconds after it passes through the intersection. All right, so we're 4 seconds of time have gone by. So my overall shape is this triangle. Now I'm not talking about an angle. So since I'm not talking about an angle, I'll be doing Pythagorean theorem. So I'll say T for train, I don't know, X for my person, and D for the distance, maybe capital D. Now I was noticing on your homework that some of you were putting the, so the Pythagorean theorem would say x squared plus t squared equals d squared. Some of you on your homework were jumping to d equals the square root of x squared plus t squared. Both are true. Both geometrically are totally fine. But I feel like one is a clear winner over the other in terms of being easy to work with for derivatives. For me personally, I would stick with the x squared plus t squared equals d squared and take my derivative of that. Because if you go the other way, it still will work. But it's very messy because you're going to be dealing with powers of 1/2 and then powers of -1/2 and then the chain rule on top of that. So I would encourage you to consider sticking with the Pythagorean theorem in its original form. Okay, again, I'm not saying it's wrong. If you are sold on doing it the other way, that's fine. But I'm going to stick with my Pythagorean theorem in my original form. So my derivative is going to be 2x dx dt and 2t dt dt, capital and lowercase, and then 2d dd dt. Then I'll look back and see what numbers I am going to be putting into this derivative. So I've got the number 70. The number 70 represents the frozen position of the person. So I can put that in. Okay, so x is equal to 70. dx dt stands for the rate at which the person is in motion or is moving. And what's the value of that?
0.
Okay, person's not moving. Okay, so it's 2 times 70 times 0 plus 2 times t. I need the value of t, the train. Am I given that? Okay, I'm given 60 meters per second, so that's going to be the dt, d capital T, d lowercase t. That's the 60. But what about the value of capital T itself? How much time has gone by?
4.
Okay, and the speed of the train is? The speed of the train is 60 meters per second, and I have 4 seconds that have gone by. So every second, the train is going 60. So our total is 240. Okay, so I've got 2 times 240. That's all right. You were doing it division by 4 instead of multiplying by 4. Okay, so that's 4 seconds at a speed of 60 meters per second. Simple multiplication. 4 times 60 is 240. All right, now and now I need a d. At this moment in time, do I have d explicitly?
No.
Can I find d?
Yes.
Okay, using the basic Pythagorean theorem, x squared plus t squared equals d squared, so I can figure out what 70 squared plus 240 squared and see what that turns out to be. So that'll be the square root 70 squared plus 240 squared. Okay, yes, and that is a Pythagorean triple, so the Pythagorean triple does work out to be the nice number of 250. And then finally, dt is the speed of the distance, the gap that's growing, which is what I'm looking for in the question. How fast is the train moving away from the observer? So that's the distance or the gap between the observer and the train. So now you have all the pieces in place. We know that the 0 is going to wipe out that 2 times 70. And so we'll end up with dt being 2 times whatever 240 times 60 all over 2 times 250. So I don't usually multiply it all out. I just kind of leave it in its multiplication form, and then I can see that my 2's will reduce. I've got a couple zeros that can reduce. So I really have 240 times 6 over 25. And then I use my calculator to evaluate that. And the units, I'm measuring the distance. So the numerator is measuring the distance. So that'll be measuring my meters. And then the time is measured in seconds.